Dear students, Assalamu alaikum. Hope all of you are fine. Welcome to Chemistry First Paper Class English version arranged by KPB School and College. Today I am going to discuss about classification of elements on the basis of electronic configuration and ideal elements or representative elements under chapter 3. The title of the chapter 3 is Periodic Properties of Elements and Chemical Bonds. This chapter is very important for your exam. You will get two creative questions in your board exam from this chapter. Moreover, this chapter has discussed the fundamental topics which will help you later on to understand other chapters. You have already learned about periodic table back in class 9, 10, but for your convenience we will revise it again. In periodic table, elements are arranged in 7 horizontal series called periods and in 18 vertical columns called groups. But in modern periodic table, there are 7 periods and there are groups like 1 to 7 with A and B subgroup and group 8 and 0 groups. Look at the figure please. Here this is group 1 and this is group period 1, this is period 1 and this first period contains only two elements. That's why it is called very short period. And this is period 2 and this is period 3. And second and third period, both of them contains only 8 elements. And that's why they are called short period. And group 4 and 5, both of them contains 18 elements. Group 4 and 5, both of them contains 18 elements and they are called long periods. On the other hand, 6th and 7th period, this is 6th and this is 7th period, both of them contains 32 elements and they are called very long period. And left to right, from left to right, there are 18 groups, total 18 groups. Now I am going to discuss about classification of elements based on electronic configuration. The elements in the periodic table are classified into 4 classes according to their electronic configuration of the outermost sublevel. Number 1 is block elements. Elements of group 1 and 2 and helium are included in S block elements. Number 2, P block elements. Elements of group 13 to 18 except helium belong to P block elements. Number 3, D block elements. Elements of group 3 to 12 are included in S block elements. And lastly, F block elements. Lanthanide and actinide series belong to F block elements. Now I would like to discuss about S block elements. The elements in which the last electron enters into the s orbital of their outermost energy level are called s block elements. The electronic configuration of the outermost energy level is ns1, ns1, and ns2. Total elements are 14, out of which one is inert gas, that is helium, and the rest are metals. Group 1, whose electronic configuration, that means outermost electronic configuration, is ns1, and group 2, whose outermost electronic configuration is ns2 and helium. These 14 elements belong to S block elements, and the NS1 elements except hydrogen are called alkali metals, and the NS2 elements are called alkaline earth metals. Now I am going to discuss about some properties of S block elements. You have already known that the outermost energy cells of these elements have ns1 and ns2 electronic configuration. They are quite soft and can be cut with knives. They form colorless compounds. They behave as strong reducing agents. They conduct heat and electricity, and the elements from lithium to francium are alkali metals as they form oxides and hydroxide having strong basic properties. And the elements of beryllium to radium form oxides which are basic, and these elements are found on the earth crust. So they are called earth alkaline metals. The sources of alkali and alkaline metals are ores. The alkali metals lost the only electrons from the outermost energy level very easily to become positively charged cations. That means alkali metals means group 1 elements except hydrogen easily become positively charged cations to lose the only outermost electron. And they have some properties. They have plus 1 oxidation state as sodium plus, potassium plus, etc. They are strong electropositive elements. They have very low ionization potentials. They are highly reactive. They are so reactive that sodium and potassium catch fire with contact with water. They form ionic compounds with nonmetals. The same properties of alkali metals are also observed in case of earth alkaline metals, that is group 2 elements. Only difference is that electronegativity and chemical reactivity are less compared to alkali metals. Now I am going to discuss about p block elements. The elements in which the last electrons enter to the outermost p orbitals are called p block elements. In this category, there are 36 elements of, that means elements of group 13 to 18 except helium. Look here, the elements of group 13 to group 18 except helium, that means total 36 elements belong to p block elements, and their outermost electronic configuration is ns2 np 1 to 6. This is the outermost electronic configuration of p block elements. Now I would like to discuss some general properties of p block elements. You have already known that the p block elements have outermost electronic configuration ns2 np1 to 6. Most of the elements are non-metals. A few are metalloids and rest of them are metals. If we look the previous picture, please see here the blue color elements represents metal. That means these are metals, and green color elements represents metalloids. Green color elements are metalloids. Metalloids are elements which show both the properties of metal and non-metals, and the violet color elements are non-metal. Here the violet color elements are non-metal, and lastly the pink color elements are radioactive elements. Now most of them have changeable oxidation state. They may act as both oxidizing and reducing agent. Most of them form covalent compounds. Their ionization energy is less than that of S block elements. Some nonmetal oxides are acidic in nature. For example, phosphorus pentoxide, nitrogen dioxide, sulfur dioxide, etc. But metal oxides are amphoteric. That means metal oxides react both as an acid and as a base. These elements react with oxygen, water, and halogen atoms. Among the p block elements, group 13, that means group 3a, group 14, that means group 4a, halogens and inert gases are notable. Now, I would like to discuss some properties of halogens. Halogen, uh, it belongs to group 17. The oxidation number of halogen is -1. Electronegativity is high. Their electron affinity values are high. Above all, they are highly reactive nonmetals. They are the most highly reactive elements among the nonmetals. Now, we have to know some properties of inert gases. Inert gases are chemically unreactive. Their valency is zero, they are monoatomic, their position is just near the most highly reactive halogen. Although they are chemically inactive, under certain conditions, actually very few conditions, they react. They have special uses in street lights, in decoration, tube lights, in instrument, etc. Radon is used for non surgical treatment of cancer, radiotherapy, etc. Now, I would like to discuss about D block elements. The elements in which the last electron enters to the d orbital are called d block elements. The electronic configuration of this category is n minus 1 d 1 to 10 ns 1 to 2. This is the electronic configuration of d block elements, and the d block elements which have partially filled d sublevel, that means that means d contains 1 to 9 electrons in each outermost level in the stable ionic state, are called transition elements. On the other hand, we can say it easily, uh, when el- d block elements form ion, their d orbitals is partially filled, that means 1 to 9 electrons. Their d orbital contains 1 to 9 electrons. In that case, these elements are called transition elements. And group 3 to 12 exist d block elements. Now I am going to discuss some properties of d block elements. You have already known that most of the elements of d block are transition elements. So we have to know some special properties of transition elements. The oxidation numbers of transition metal are changeable. The transition metals form colored compounds. Transition metals and their compounds act as catalysts. Transition metals or ions form complex compounds. They show paramagnetism due to the presence of unpaired electrons in the d orbital. They are metals of high melting and boiling points. They have high densities also. Now I am going to discuss about F block elements. The elements in which the last electron enters into the f orbital are called F block elements. They consist of two series of elements placed in two rows at the bottom of the periodic table. They are lanthanide series, start from cerium and ends at lutetia, and actinide series starts from thorium and ends at lawrencia. The lanthanides and actinides together are called inner transition elements. That means F block elements are also known as inner transition elements. The some common properties of a block elements are they have high melting and boiling point. They show variable oxidation states, the most common oxidation state being 3 plus. They form colored salts because these salts absorb light of certain wavelength to form visible light. Actinides are radioactive elements. They have also high densities and they are paramagnetic. That means these are metals that are weakly attracted to magnet. They show close similarities in chemical reaction among the series numbers. Now I would like to discuss about ideal elements or representative elements. The two groups of S block on the left, that is, this is one group and this is two, number two group. These two group of S block on the left and the sixth group of P block on the right, that means one, 2, 3, 4, 6. These six group on the right are the ideal elements or representative elements because they follow the general rules in filling their orbitals with electrons without any exception. That means we do not show any exception of electronic configuration of, of electronic configuration of ideal or representative elements. I hope this class was helpful for you as this chapter is very important. Like I said earlier, you have to revise this class again and again. No more today. Thank you, everybody. Take care. Bye.